Okay, so we're going to talk about solving systems of linear equations in 3 variables. I'm going to give you a couple additional problems so that maybe if you didn't get it from the previous videos that you did, you can from mine. I put the steps on there, even though you might have seen them before. And we call the variable that we initially eliminate we call that our focus variable. And I'm going to mention that again in a minute. All right, so let's look at the first problem. So what we're trying to do is get it down to 2 equations with 2 variables like we did in the previous section. And so we look at this and say, okay, which is the easiest one to eliminate? And it doesn't really make any difference which one you eliminate, but I'm going to use y in this one just to be different. So I'm going to look at trying to eliminate the y's. And then I'll have 2 equations that have x and y, x and z in them. Then I can solve for x or z. So we're going to call our y our focus variable. So if I'm looking at the y's, if I just add, well, let's number 1, 2, and 3. These are the equation numbers. If I take and just add 1 and 2 together, my y should cancel out. They have the same coefficient. One's a negative and one's a positive. So I'm going just as simply to add equation 1 and 2 together. So x plus y plus z equals 2. And the biggest thing to remember when solving for these equations is that you be very particular, because one sign will mess up this whole process. It's not a hard process, it's just you have to be very, very careful. So if I can try not to multiply by negatives or try and multiply by multiple things, then it reduces my risk of error. So I'm going to add these 2 together. So my x and x make 2x, negative 1y and negative y equals 0. 2z plus 1z is 3z. 2 plus 2 is 4. I have created one of the 2 equations that I need, and I'm going to label that equation 4. Now I need to eliminate, I've picked y and I have to stick with y. I'm going to eliminate y from two other equations. So I'm going to choose equation 2 and 3. And by looking here, if I multiply this by a 2, I'll get a negative 2 and a positive 2 when I add them together, and the y's will eliminate. So I'm going to multiply equation 2 by 2. So I'm going to rewrite that. This is equation 2. X minus y plus 2z equals 2. I'm going to multiply this by 2. So I get 2x minus 2y plus 4z equals 4. And again, I go and I check, did I do my multiplication right? Because if I make an error here, nothing else is going to come out correct. And now I'm going to bring along equation 3. Negative x plus 2y minus z equals 1. And again, I'm going to add these 2 together. So this gives me x, these should eliminate, plus 3z equals 5. So now I've created the 2 equations that I'm going to work with until I get to the very, very, very end of my problem. So now I'm going to work with these 2 equations to the very end. So now I'm going to eliminate either the x and multiply this by a negative 2, or I could eliminate the z's by just multiplying one of these equations by a negative. So I'm just going to choose to work with the z's because I just have to do one easy multiplication. So I'm going to multiply equation 4 by negative 1. So that becomes, so this is equation 4, I'm multiplying it by a negative 1, negative 2x minus 3z equals negative 4. equation 5, I'm just going to bring along. So x plus 3z equals 5. Now I'm going to add these two together. I get negative x, these eliminate. Negative 4 plus 5 is negative 1, positive 1. Multiply both sides by negative, I get x equals negative 1. Hip hip hooray, I got the x. Once I get the x, or one of the variables that I've worked for, I'm going to plug that back in to either equation 4 or 5. If I go back and plug it into one of the original equations, I'm still going to be left with two variables and I still can't solve it. So I'm going to plug or substitute x equals negative 1 into equation 4 or 5, and it makes no difference. So I'm going to say x is negative 1, and I'm going to use equation 4. So I'm going to plug in 2, back up here, times negative 1 plus 3z equals 4. This is negative 2 plus 3z equals 4. I'm going to add 2 to both sides. Z equals 2. Now I have two variables. Now I can go back x equals, let's get something a little darker here. X equals negative 1 and z equals 2. I can substitute or plug into equation 1, 2, or 3. And just for simple purposes, I'm just going to use equation 1. So the equation is x plus y plus z equals 2. So if x is negative 1 and y is y and z is 2, when I add the combined like terms, I get 1 plus y equals 2, subtract 1, y equals 1. So these three planes meet at the point xyz, and it needs to be put in xyz form. So it would be negative 1, 1, 2. Okay, I've started a second problem, and I'm going to eliminate x first. And what I did is I chose to multiply equation 1 by negative, so that makes it a negative x, negative 3y, a positive 6z, and a negative 7. And I'm going to add that to the third equation. So that's x plus 2y plus 2z equals negative 1. I'm going to add these two together, so these should cancel out. I get negative y plus 8z equals negative 8. I have made equation 4. Okay, so now I'm going to look at, again, eliminating x. So I'm going to multiply equation 1 by a negative 2. So I'm going to multiply equation 2 by, no, I'm going to multiply equation 1. So I'm going to multiply equation 1 by a negative 2. So that makes it negative 2x minus 6y minus 12z equals negative 14. So let's go back and check. Negative 2 by negative 2 would be negative 6. By negative 2 would be a positive 12x, and a negative 2 would be a negative 14. So negative, negative, positive, negative. Okay, so now I'm going to bring along equation 2. So 2x minus y plus z equals 1. Add them together, I get negative 7y plus 13z equals negative 13. I have made equation 5. So again, I'm only going to work with these two from now on until I get to the last step. So if I look at these two equations, I could multiply this by 13 and this by a negative 8, but let's not get big numbers. So if I just multiply this by a negative 7, then this would make this a positive 7y, and this would be a negative 7y. So I'm going to multiply equation 4 by a negative 7. So that makes that 7y. Oh, it's going to make it a negative, right? So it'd be a negative 56z equals a positive 56. Okay, now I'm going to bring along equation 5. So here's equation 5. So negative 7y plus 13z equals negative 13. And I'm going to add them together. I get, 33, negative 43z equals 43. Divide by negative 43, I get z equals negative 1. All right, now I have 1, so I'm going to choose to either put z equals negative 1 into 4 or 5. And I'm going to plug it in. I'm going to use equation 1. So I'm going to plug in z equals negative 1 into equation 4. So negative y plus 8 times negative 1 equals negative 8. Negative y minus 8 equals negative 8. Negative y, I'm going to add 8 to both sides, and I get 0, so y equals 0. So now I have z and y, and now I'm ready to plug back in to the original equations. So now I'm going to use equation 1. That's the only time that you can go back. And let's use a different color here. So I'm going to plug z and y into equation 1. And equation 1, let's just double check, make sure I get the right, x plus 3y minus 6z. So x, I don't have that because I eliminated it first. X plus 3, y is 0, minus 6z is negative 1, equals 7. I get 0 here, so x plus 7, no, that's not 7, oh my goodness. I get positive 6 equals 7. I'm going to subtract 6, so I get x equals 1. So these meet at a triple at one point, and remember it's x, y, z. So my x value is 1, my y value is 0, and my z value is negative 1. Okay, let's start. We're not going to have time to start this one. Let's look at this one. This is a little different. I will resume this one in another video. This one's a little different because this one only has 2 variables.